All right. So what we're covering today is really special factors. Each one of these factors kind of in a unique or special way. So when we look at the first one here, this one here really is going to be what we call a perfect square trinomial, in that it's going to factor and come to the form of a squared plus b squared, or a squared minus b squared. And having this written down really isn't that important, because how these end up factoring or expanding out is into the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, and we can expand or contract these or factor them back out or expand them. And really trying to use these formulas really doesn't save any time, because it's just going to be just as fast to actually factor them the way that we've been doing the last 2 days than it is to actually work out that formula and use it there. So if we were to factor this here, we would look for first a greatest common factor between these three terms. Well, since the third term is 1, well, there's not a greatest common factor between them. So we can rewrite, so we can start off by writing our 2 sets of parentheses with 3 spaces.
Hi, I was just wondering if Mrs. Buchanan was in here. No?
Nope.
All right, thank you.
You're welcome. Now the next thing we're going to find is the signs. Since the third term is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. And then we need to find the factors of the first and third term. Well, our first term is 4x squared and our third term is 1. Now the factors of x squared are going to be x and x. And then we need to look at the factors of 4. Well, 4 is 1 and 4, or 2 and 2. Which one do we want to try first? 2 and 2. And now we need to find the factors of 1, which is, well, 1 and 1. Because the only numbers that multiply together to give us 1 is 1 and 1. And incidentally enough, 1's actually not prime. Because for a number to be prime, it has to be multiplied by 1 and its self. 1's the only number, so it's not considered to be prime. And if we check this here, 2x times negative 1 would be negative 2x. Negative 1 times 2x is negative 2x. And negative 2x minus 2x is negative 4x, which is the middle term that we wanted. So this here would be the factored form of 4x squared minus 4x plus 1. But we could actually rewrite it as 2x minus 1 squared. Because since both sets of parentheses are the exact same, we can condense it down to one set of parentheses squared. That's what kind of makes these here special, is that we can actually rewrite it as a set of parentheses squared, since they're both the exact same. And I feel like for the most part, doing it this way here and trying to utilize the formula, you're not saving time either way. So it's a little bit easier to do it this way than it is to try to memorize the formulas and break them down that way. Any questions on this here? All right, let's look at the next one. 16b squared minus 40b plus 25. Well, we can first look for a greatest common factor between these three terms, which there is not one. So we can do our 2 sets of parentheses with 3 spaces. Now, since the third term is positive, the signs are the same and they match the sign of the middle term, which is negative and negative. So now we need to find the factors of the first and third term. So the factors of 16b squared, well, we would have b and b for sure. Now the factors of 16 is going to be 1 times 16, 2 times 8, and 4 times 4. So which ones do we want to try first? 4 and 4. It's got to be a giveaway since we're talking about the special cases. So since it does work out that one of the factors of 16 is 4 and 4, most likely it's the one that's going to work. Now if we look at the factors of 25, we have 1 times 25 and 5 and 5. So most likely we're going to use 5 and 5. And again, if we were to check this, 4b times negative 5 is negative 20b. Negative 5 times 4b is negative 20b, which gives us negative 40b, which is exactly what we want. So these here are the factors, or really we can rewrite it as 4b minus 5 squared. Either one of those works just fine. Any questions on any of this here? I'm not going to make us work through this one here because it's going to work out the exact same, except the signs inside the parentheses will not be negative. They're going to be positive because the middle sign is positive. But any questions on these here? Let's look at this one here, n squared minus 25. Now we can work through this and factor this through like we did on the ones before. Since there's not a greatest common factor, we can write our 2 sets of parentheses with 3 spaces. Now we don't technically have a third term, but we also don't have a middle term, because n squared we don't have a number times n. So really our third term is the negative 25. Now because it's negative, our signs are going to be opposite. One's going to be positive and one is going to be negative. Which leaves us looking at the factors of the first and third term. Well, the factors of n squared are n and n. Now the factors of 25 are 1 and 25, or 5 and 5. Which one do we want to use? 5 and 5. We can try it first. And it works out that this is the correct setup, because if we check it, n times negative 5 is negative 5n. 5 times n is plus 5n, and negative 5n plus 5n is 0, which is what we expected and what we wanted, because we did not want to have a middle term. There is no middle term here, so these here would be the correct factors. Any questions on this here? Now this setup, and just like with the next one, here is actually following a specific definition, a squared minus b squared. It is the difference of perfect squares. And whenever we have the difference of perfect squares, it will actually factor down to a plus b times a minus b. If we have two terms that are perfect squares, being subtracted, it will always factor in this way here. So if we look at the one before, well, n squared and 25 are both perfect squares, because the square root of n squared is n, square root of 25 is 5, so we end up getting n minus 5 and n plus 5 being multiplied together. Now if we look at this one here, is 16n squared a perfect square? Because what times itself is 16n squared? 4n. So we can kind of look at it in the term of 4n squared minus, well, what times itself is 9? 3 squared. And this is how most textbooks will actually rewrite it out, is they're trying to signify and show what the values of a and b are. So for here and here, we're going to be plugging in 4n, as it's our a squared, so a is 4n. And in this case, b would be what? B would be the 3. Because a squared minus b squared, a and b are 4n and 3. So really we could say that this is 4n plus 3 times 4n minus 3. Questions on this here? And if we wanted to, we could check to see if this does work. 4n times negative 3 is negative 12n. 3 times 4n is plus 12n, which gives us 0. Exactly what we wanted. So 4n plus 3 times 4n minus 3 is this factored. Now we could have written it the other way and said 4n minus 3 times 4n plus 3. That's the same thing. It's just flipped. Any questions on this here? Now, I go with the formula on this one here because the formula actually does save us a little bit of time working these here compared to the perfect square trinomials that we started out with. Any questions on this here? So let's look at this one here, 4m squared minus 25. Is 4m squared and 25, are they both perfect squares? Well, yes, 4m squared is really just 2m times 2m. And 25 is the same as 5 times 5. So both of these are perfect squares, yes? So if I wanted to factor this, it would factor in the form of what? 2m plus 5 times, and that's it. And I usually find that most students find these their favorite ones to factor is because they're a little bit easier to factor than the rest. They're both perfect squares, so it's really the square root of each plus and minus. And that's it. Any questions on this here? Get ready for the next one. A to the 4th minus 9. Are these perfect squares? Is 9 a perfect square? Yeah, because we can say 9 is 3 times 3 or 3 squared. A to the 4th. Is it a perfect square? Can I take the square root of a to the 4th? It actually can. It actually works out that this is a squared. Because we can write it as a squared squared, because powers of powers multiply. In other words, what we're saying with a squared squared, is I'll write it in a different way, is that we're saying that we have a squared times a squared. Because whenever like bases are being multiplied together, we add the exponents. Well, 2 plus 2 would give us 4. So with this here, we actually do have the difference of perfect squares. And it would work out that we have what? A squared plus 3 times a squared minus 3. So as long as both of them are perfect squares, doesn't matter what they are, we can actually factor this using the difference of perfect squares. Questions on this here? Now we do have to be careful in that this here, a squared is still a perfect square, yes? And we do have a subtraction. Now is 3 a perfect square? Well, no. But if this here, the second one, a squared minus a number, if that other number was also a perfect square, so say 4, if it worked out to be a squared minus 4, well, that would also still be a perfect square, yes? Difference of perfect squares, we would have to factor it again. Bless you. Bless you. So on these here, we do kind of have to pay attention to them. Now the a squared plus 3, well, 3 is not a perfect square, and they are being added, not subtracted. So it wouldn't actually factor down further. So for this here, this would be them completely factored, or with real numbers and rational numbers. This would be the complete factorization. They might throw one of these here, something like this here on the ACT, they might, and say factor it completely, and they might give this as the final answer. Well, this here, for this one, it would be. But if it worked out that it was, say, 4 instead of 3 in both of those spots, it would not be completely factored. We'd have to take it a step further. And we'll see an example of that here in a minute. But any questions on this here so far? Let's look at this one here. Well, as we just saw, we can say that this is the difference of perfect squares, yes? Because k to the fourth is really k squared squared. K squared squared, and 36 is what? 6 squared. So this here would factor down to what? K squared plus 6 times k squared minus 6. We could have said k squared minus 6 times k squared plus 6. Either one of these would be correct, because luckily with multiplication, order does not matter. We can multiply any two things in any order. So either one of these is the correct answer. Any questions on this here? And this here would be the correct answer because 6 is not a perfect square. Let's look at this one here. So this one here is not on the note sheets. I realized that this morning. I don't know why I didn't fix it when I wrote these up originally, but when I did these the first time through, I think last year, hopefully, I'm hoping it's last year, not the year before, because that would mean I'd let this slip twice. This would be the second time. I actually wanted one to where it would actually factor, where we would get perfect squares. Because if we look at this here, x to the fourth, well, we can say that this is x squared squared, like we've done on the last two. Now, 81 is what times itself? 9 squared. So this here would factor to x squared plus 9 times x squared minus 9. And this is where it differs from the other two, because is 9 a perfect square? Yes, because 3 times 3 is 9, which means this part of the factorization is still a difference of perfect squares. We can still factor it. Now the x squared plus 9 is going to stay the same, but the x squared minus 9 is going to become what? X plus 3 times x minus 3. And this here will be completely factored. So if, on a standardized test, especially if they gave you this problem here, x to the fourth minus 81, factor it completely, they might be a little mean and put this here as one of the answer choices. But because they said factored completely, it would not be correct because we would still have to factor the x squared minus 9 down one step further because it's not factored completely. Questions on this here? No, because this here doesn't have actual real factors. We would have to be able to find its factors, we would have to technically almost solve it. Actually, not almost, we would have to solve it to get down to its factors of x plus 3i times x minus 3i. Take it. Most, it depends on what they're talking about. Most will take it as this here as being factored completely. Here, to get these two factors, you have to take x plus 9. Well, it would jump back up. Still haven't quite figured out why it's doing that. So x squared plus 9 and set it equal to 0 to solve for the value of x. So we would subtract 9 from both sides, telling us that x squared is equal to negative 9. From there we would square root both sides, telling us x is equal to plus or minus 3i. Then we would set really x is equal to 3i and x is equal to negative 3i. So here we would subtract 3i from both sides, really getting it back equal to 0. Here we would add 3i, x plus 3i, which tells us that the factors of this here kind of factors down to this here. But for most, when we talk about kind of the real factors, we're going to stick to this here. Most of these here, especially if we're talking about irrational solutions or factors, is when we start talking about the kind of having x plus square root of 4 and x minus 41, something like this here. And the only real way to get to that is, again, like we did with the last one, we have to solve it out. So most of those they don't include with factors because they're a little bit more intensive to get to. Does that make sense? I don't see them getting to this part here, but I do see them getting to at least here. Does that make sense? Any other questions on this? We good with this here for the most part? All right. So the fourth roots dealing with x to the fourth, or the difference of perfect squares with fourth powers, is kind of new. We didn't cover that last semester. And the rest of this note sheet is going to be new, because the sum and difference of perfect cubes in the other section is the factoring by grouping. We didn't cover. We didn't have time to cover it. This part isn't included in the note sheets because I wanted to just show you the different formula and how this works. Okay? All right. And what's interesting is it still works out because it's works out to be the same, opposite, always end on a positive note. And it's kind of a nice little way to remember. It kind of sticks in your head so that you can actually remember what the signs are. Same, opposite, always end on a positive note. And it's not too bad to work out these and how they factor. And really for a standardized test, that's actually kind of helpful. Because even if the rest of this is kind of fuzzy, if you remember how to do the signs, it helps out. Because if we're looking at the answers, and well, for the difference of perfect cubes is positive, Any of them that don't have the same opposite always end on a positive note aren't going to be the correct answer. Now how it works for the rest of them is if we take the cubed root of both of these here and get a and b, well, we'll have a squared a, and here is actually a to the 0. And then for b, we actually have b. Here is actually b to the 0, b to the first, and b squared. So in the second set of parentheses, it's actually, for the first term, it's going squared to the first power 0. And for the other, it's going from 0 to the first power squared. Now this will make a little more sense when we look at the first example. So let's look at this here and see how this works, because it'll work out a little bit easier than you might think. Now the first thing I do is check to see if we can do this by taking the cubed root of both terms. We're not so much worried about the sign. We're just wanting to see if I can take the cubed root of x cubed and the cubed root of 125. Now looking at this here, the cubed root of x to the third is x. Variables are not too bad to take the cubed root of. Now we need to take the cubed root of 125. Anybody know? It is 5. Now the way that we can do this in the calculator, if we have this here, is if we go math and down to the fourth one, the 3 radical will be the cubed root. The one below it is the nth root, so we can put whatever number we want in for x to take it. So if we want to take the 4th root, 5th root, 27th root, we would do the one below it. So this here would be the cubed root. And we want 125. So we can type that in there and hit enter, and it will tell us that it is 5. In the graphing, or in the yellow calculators, if we do second, the little caret key, which we normally use to put in different exponents besides 2, we'll do the same thing. We can get it that way. So what that tells us for this here is that both of these are perfect cubes, and we have the sum of perfect cubes. So we can set up our parentheses to work this out. Now I call this set of parentheses the tractor trailer, because most of y'all have seen a tractor trailer hopefully at some point. Because our first set of parentheses is going to be 3 spaces, kind of like the cab, and the second one actually has 5. Smaller and bigger, it kind of looks like a tractor trailer. Now we're going to plug in our signs. And the signs for any of these here are always going to be the same, opposite, always end on a positive note. So the same would be matching with our plus. So our first one would be plus, because it's the same. Opposite would be minus, always end on a positive note. And we're leaving spaces in there for our other terms, because the first term and the second term, where we're plugging in dealing with the x and our 5. Any questions on any of this here so far? So when dealing with the signs, is our first, the sign that we started out with is plus. So inside this here, the first sign is always going to be the same as what we started with. So since we started out with plus, it's going to be plus. Our second sign is always going to be the opposite of what we started with. So minus, and then we always want to end it on a positive note. And with any of these here, we're actually going to work out to have 2 addition signs and 1 subtraction for any of them here. So when we look at these here, well, if it starts out as a cubed minus b cubed, well, we have 2 inside the bigger set. And as the one we have here, first and second. Does that kind of answer that? Any other questions before we start plugging in our first set of terms? Okay. Now, x cubed was first, because it's x cubed plus 125. So x is going to go first. On our first blank here, we're going to have x. In the smaller one, they're always going to be to the first power. And we'll go on and finish plugging the x's in. In the bigger one, in the first one, we're going to have our x to the second power. That first term to the second power. In the next spot, we're going to have x to the first power, or just x by itself. And in the last one, we technically have x to the 0 power. I'm going to write it above it because I don't normally write this in, because anything to the 0 power is 1. So it's just going to simplify to 1. So it normally doesn't get written in. And the next part we have is 5. Our first smaller one, we will have 5. This here is technically 5 to the 0 power. Well, anything to the 0 power is 1, so we don't have to write that in. The middle one, we're going to have 5 to the first power, or just 5. And then we're going to have 5 squared. So in the first set, we have x and 5 both to the first power. And in the bigger one, the first term, our x, is going squared, really to the first power, and then to the 0. And the second one, our 5, well, here it's 0 to the first and then squared. You'll kind of see how the powers are both, one's decreasing and one's increasing. 2, 1, 0, the other's going 0, 1, 2. Any questions on how we set this up? No? Are we ready for the next step? Simplifying. Which means that we're not really doing anything to the x plus 5 because there's no real powers, nothing going on there. Now in the second set of parentheses, well, we have x squared, which is just x squared. It only really makes a difference if we have a number with the variable. Minus. In the middle, we have x times 5, which is 5x. Plus, our last one is 5 squared, and 5 squared is 25. And that's it. That's all we have to do for this here. A little bit easier than y'all thought that was going to be. Yeah. So really, when we're plugging into the bigger part, the number that we got for the first, taking the cubed root, squared first, 0. The other ones, which in this case is 5, is going to the 0 power to the first and then squared. Any questions on this here? We good? All right. Let's look at one more. So here we want to see if we can take the cubed root of x cubed and the cubed root of 64. Yep, we're right here. You're good. You'll have space. Most likely we won't get to that one. Now the cubed root of x cubed is x. Now the cubed root of 64 is going to be 4. Now the way that we can find that on the calculator, because we can do that on the calculator, I'm not expecting y'all to have cubes memorized, is we can come down here to the cubed root and type in 64, and it'll tell us that it is 4. So this tells us that both of these are perfect cubes. So that means we have the difference of perfect cubes. and we can set up the tractor trailer. So the first one's going to have 3 spots and the second's going to have 5. Now inside the first set of parentheses, so, well, our signs is always going to be the same, opposite, always end on a positive note. Well, we're starting out with a subtraction, so the same would be negative, opposite would be positive, and always ended on a positive note. So for this time, we would have negative, positive, positive. Any questions on this here? Now we can go on and plug in the first term. So here we're going to have x, and in the bigger one here, we're going to have x squared, and then x to the first, and then the last one would technically be x to the 0. So we don't have to write it in, because we know that it's going to simplify to 1. Now for our other term in the first set of parentheses, we're going to have 4. The next one would technically be 4 to the 0, which is 1. In the middle, we're going to have 4. And lastly, we're going to have 4 squared. Any questions on this here before we simplify down? So what this will simplify down to is x minus 4 times. This here would be x squared plus 4x plus 16. And that would be this here factored. Any questions on any of this here? Now, most likely we might have some time to squeeze the next one in, but I'm going to stop here and we'll finish this tomorrow. So we have 1 or 2 more that I want to do with sum and difference of perfect cubes, and then we will finish off with factoring by grouping.